But all key policy decisions are made behind these doors. Chairman Alan Greenspan is about to convene a meeting of the Fed's Board of Governors.
Good morning, everyone. I trust you all had a pleasant weekend. Shall we get started?
Thank you.
The men around this table exercise more power than any other group of bankers in the world. They set the interest rates that banks pay to borrow money and that Americans end up paying for houses and cars. They run the systems Americans use to pay their bills, be they cash, check, credit card, or computer. Their goal is to grow the economy without inflation.
What you're trying to avoid is big swings up in the economy, which inevitably lead to a collapse in the economy.
But these days, the job of the Federal Reserve has gotten harder than ever.
With the advent of new technology, particularly electronics, and new structures for banking systems, all of these things are adding enormously to the complexity of conducting central banking.
To see how the Fed is facing these challenges, we must come first to New York City, the world capital of finance. Just 3 blocks from Wall Street sits the Federal Reserve Bank of New York. It's the largest and most important of the Fed's regional banks. It occupies an entire city block. The bank was built in 1924 and modeled after a Renaissance Italian palace.
Our Federal Reserve banks serve as a tangible, visible symbol of the financial system that they represent and that they serve.
A central bank ought to look like a really serious, solid place. It's dependable, you can count on them. So it was meant to give a psychological message, and it still does.
The New York Fed is the only bank allowed to conduct business with foreign governments in the name of the U.S. government. The amount of that business has grown enormously. But like every other Federal Reserve Bank, the New York Fed also helps to regulate the local banks in its area and lend those banks money. The interest rate at which the Fed lends money to other banks is determined on the open market trading floor.
The function of the open market desk is to perform the nuts and bolts operation that is necessary for the Federal Reserve to control that basic interest rate upon which all the other interest rates are built.
Only one item is bought or sold here: U.S. government securities, IOUs from the federal government. As much as $185 billion in a single day. This is the Fed's primary tool for raising or lowering interest rates.
The effect of it is we add or we subtract money to the banking system. If you add money to the banking system, it has the effect of bringing the interest rate down. If you pull money out of the banking system, it has the effect of making the interest rate go up.
Another unique role that the New York Fed plays in the banking system may come as quite a surprise. 5 stories below street level is one of the deepest basements in Manhattan. With just a few turns of the hand wheel, a 90-ton steel cylinder rotates to open an air and watertight vault. Inside is gold. More gold than at Fort Knox. More gold than in any other place in the world. About $70 billion worth. Remarkably, 98% of this gold belongs to foreign countries and not to the United States.
When foreign central banks want to keep their gold in a really secure place, they keep it at the Federal Reserve Bank of New York.
Each gold bar weighs 28 pounds, worth about $118,000 at today's prices. The workers must wear metal covers over their shoes to protect their feet. There's not much high-tech about transactions in gold. The bars are literally moved from a country's compartment by hand. Every time there's a transaction, the bars must be weighed using an old-fashioned mechanical scale. The senior vault custodian confirms all gold transactions. The process may look primitive, but it can measure weights lighter than a single grain of rice. Sometimes the gold is transferred from the Fed to another location. That's done by a private security service. But to many of these outside companies, the gold is just another product to be moved. Perhaps that's because gold no longer has anything to do with the value of the US dollar.
It is the faith in the government of the United States that gives the U.S. currency its value. It's not backed by gold. It's not backed by anything except people's confidence in the United States of America.
It is electronic payments, not gold, that are the Fed's future. These are the first pictures ever allowed of the Fed's Network Command Center. Its exact location is kept secret. It's the hub of the electronic payment system called Fedwire. This is the way banks and big institutions pay each other. In the blink of an eye, millions can be transferred from one account to another. It's the fastest form of payment, the cheapest, the safest, and the most important. Every day, almost $2.1 trillion moves through this room. That's almost 50% of all money in the United States.
If one of our electronic systems went down in the middle of the day, it would bring the economy to a halt very quickly. It would be a very serious event, and we have to be very careful to maintain our systems on an up or go basis.
Sums of money, but a larger number of transactions are done by check. Americans write more checks than any other nation in the world. Every bank of the Federal Reserve processes checks, and New York is one of the busiest. The machine can scan 1,800 checks a minute. The Fed expects that electronic payments will one day replace these checks. In addition to processing checks, every bank of the Fed also provides a more traditional banking function, keeping cash safe. This is the Federal Reserve Bank of Cleveland. In the 1920s, guards with machine guns hid in these statues to keep away bank robbers. Even though no Fed bank has ever been robbed, security remains a concern. So when the Cleveland Fed recently spent $117 million to remodel, part of the money went to upgrading the security system.
I can't really tell you how many cameras are located around the bank specifically. It's sort of a security concern, but let me suffice it to say it's in the hundreds of cameras throughout the bank, sort of watching everything. You really can't go anywhere without being on camera.
But it's the unseen devices that really make the protection state-of-the-art.
The protection is really advanced to a Star Wars type of technology, which includes such devices as heat, vibration, sound, microwave, infrared, and even biometric scanners we have now in certain places.
All of this security serves one purpose: to protect the contents of armored cars like this one. Deliveries arrive throughout the day from the 480 regional banks served by the Cleveland Fed. In 1996, the Federal Reserve agreed to 9 changes in the design of all U.S. currency except the $1 bill. The most visible change was a new and larger portrait set off center. But turning the new designs into actual money was an enormous undertaking. It began in this attic studio at the Bureau of Engraving. Engraver Will Fleischl transfers a wax outline of the new Lincoln portrait onto a clean piece of 1/4-inch steel. Next, he'll begin to cut that design into the plate by hand. No cut can be deeper than the thickness of a human hair.
It's hard to even see the lines that I engrave without a 6-power to 10-power glass, and that's purposefully done.
The minute details make the portrait harder to copy accurately, but they also make the engraver's job harder.
You have to learn to control your breathing. You have to get used to looking under magnification for long periods of time.
Perhaps the biggest challenge facing the engraver is working in reverse.
Drawing in reverse is kind of a conundrum. I mean, you have to trick yourself all the time.
It can take up to 8 months to complete a single portrait.
I enjoy watching the image develop. This was a great man, but at the same time, he had a really raucous sense of humor. He was the kind of a guy that you could talk to. I try to convey that.
The use of portraits on the face of the currency is actually done for a security reason. People are used to looking at people's faces, and they can notice a lot of detail. They can notice differences, so that if someone else tries to reproduce that Ben Franklin and doesn't do quite as good a job, you'll notice that.
Another new security feature is much harder to notice. It's called microprinting. Some engraved letters are just 1/100th of an inch tall, much too small to be reproduced on a copier. All the letters are engraved by hand for 2 reasons.
Having a hand engraving rather than a computer-generated image gives us what we feel is not only the best image, but also a secure image. Even the same engraver couldn't reproduce that exact same hand-cut image if they tried again.
It's also for security reasons that no one single engraver ever does all the work. Once the portrait and letters are engraved, they're combined onto a single steel plate called a master die. There's one master die for the front of a bill and one for the back. It's from this master die that the printing plates will eventually be made, and that process is astonishingly complex. First, a sheet of special plastic is placed on the die. The die and the plastic are then baked together in an oven at 250 degrees Fahrenheit. That sets the design into the plastic plate. The finished plastic plate is measured to check the depth of the design impression. If it doesn't match the measurements of the engraved image, it will be rejected. The plastic plates that pass inspection are then joined into a sheet of 32. Next, the sheet is sprayed with a thin coating of silver. Then it is lowered into a vat of nickel solution that contains pieces of pure nickel, here seen in green baskets. When an electrical current passes through the vat, it slowly deposits a layer of nickel onto the silver-coated plastic. The entire process takes 22 hours. The original plastic sheet will be destroyed. The nickel sheet will be the actual plate that prints money. But the printing plates are not yet finished. They must first be scrubbed with a special solution to remove the silver. Then carefully ground down by a machine to a thickness of exactly 3/100ths of an inch. Next, a coat of chrome is added to harden it. Each plate is then shaped to fit the printing press. A plate can make 32 million banknotes before wearing out, so multiple working plates are made. All these plates, of course, are extremely valuable. Changing the design of U.S. currency was only one part of the Federal Reserve's program to deter counterfeiting. The other part was changing the paper. 100 years, all U.S. currency paper has been made in Dalton, Massachusetts, at the mill owned by Crane & Company.
The message to Crane is we're interested in every conceivable new form of anti-counterfeit technology, but whatever you do, don't change the feel of the paper.
The feel of the paper comes in part from the raw materials that go into it. They're actually waste products, bits of cotton, flax, and denim.
It turns out that denim, ever since its invention by Levi Strauss, has been the cloth material that has the highest quality cotton.
Some aspects of paper making haven't changed in centuries. Bales of cotton rags are loaded into the top of a huge boiler. After the hatch has been locked down, a cleaning agent will be added and the cooking will start. The boiler is 14 feet wide and is suspended 8 feet above the ground. It's made of cast iron and holds 3.5 tons of rags. The temperature inside will rise to 280 degrees Fahrenheit. After 2.5 hours, the rags have been stripped of their natural oils. What emerges is raw cellulose. But even this is not strong enough to make good paper. The fibers must be made to interlock more tightly. To do that, the rags begin a violent journey. They're mixed with harsh chemicals, beaten into a pulp and spread out over a fine mesh screen. Much of the liquid drains through. But even when the pulp is squeezed into a heavy roll, it's still too soggy to hold together. The raw paper still contains impurities. To remove them, the whole process will be repeated. This time the vat contains bleach to drain out all color. From here, the pulp is piped into a special press that squeezes out the water under more than half a ton of pressure, then cuts the paper into sheets. At this point, the paper is similar to other fine papers. But security features will now be added that will make it like no other paper in the world. The most unusual feature is this security strip, which took scientists at Crane more than 7 years to develop. It starts as a roll of plastic 2¼ miles long. The roll is cut into strips 1/16 of an inch wide. Embedded in each strip are letters, here magnified 75 times, that spell out a bill's denomination. Each letter is cut out of multiple layers of a special foil. The security strip will be inserted into the paper by a secret process. The strips have a unique property. They're not visible under reflected light, so they can't be photocopied. Only when light shines through the bill can one see the security strip.
It's very easy for the public to identify that and see whether or not it's in there. It's very hard for a counterfeiter to replicate that. If there is not a thin strip embedded in the paper of your bill, then you should be suspect of it.
For added security, the strips are dyed colors that glow under ultraviolet light. Green is for 20s. Another new security feature is actually centuries old. It's a shadow image known as a watermark. Making a watermark begins with a wax carving. Tom Gardner engraved the portrait of Ben Franklin for the watermark in the new $100 bill. After the model's finished, it's covered in copper, then pressed into a fine mesh screen. But creating watermarks from these images takes many more steps. We can get a sense of that process in the testing lab. The wire mesh with the image is clamped into a special container. The pulp is similar to that used for currency paper. As the liquid drains out, the fibers settle onto the surface of the screen. Fibers collect most deeply in the dents of the portrait. The pulp is then lifted onto a piece of blotting paper. The portrait sticks up highest. The pulp is quickly dried under a weighted cover. What will emerge is a faint portrait that's actually part of the paper itself.
It's a series of steps that have been practiced by paper makers for many, many years. We have simply refined it. It's a process that Crane holds as one of our prized secrets.
In fact, the actual process of inserting currency watermarks is so secret that it's done behind guarded curtains. Watermarks are inserted every 6 inches onto the currency paper. This sheet with Andrew Jackson watermarks will make 20s. But the paper is not yet ready for printing. It must first get a chemical coat so that the ink will stick to it. The paper then travels through a series of 25 dryers at 300 degrees Fahrenheit. Next comes a rigorous inspection.
We have to confirm and verify that all of the things that are in the paper, whether it's a watermark, a security thread, are all present in the very specific location where they belong in the paper.
14 different cameras now scan the paper. The laser burns a tiny hole wherever there's a defect.
One defect in the unwinding of the security thread destroys the paper potentially all the way across the full width of the paper machine.
Each finished roll weighs 4 tons and is more than 58,000 feet long, enough for 3,200,000 banknotes. But the inspection isn't over yet. If the paper's too damp, it may rot. So they weigh sample pieces. If any of the samples contains more than 6% moisture by weight, the entire roll will be turned back into pulp. The paper's temperature must also be within a specified range. The paper's strength will be tested on these 125-year-old machines, which push and pull a 2-inch paper sample. If a sample tears before it's folded 8,000 times, the entire roll will be rejected. Every roll that passes inspection is cut down into smaller rolls, then fed into a high-speed cutting machine. Each sheet can make 32 banknotes. Even at this point, an inspector can reject an entire roll. The finished sheets are stacked into blocks of 20,000.
By the time we're done with it, we have invested a great deal of know-how in converting these materials of almost zero value into the most prized and arguably the most valuable paper in the world.
In fact, the paper is so valuable that every shipment leaves the mill under armed guard. The paper arrives here at the Bureau of Engraving and Printing in Washington. Today, they're getting ready to print new $5 bills. Each printing plate gets a final inspection. The plates are bolted onto the printing cylinders 4 at a time, enough to make 128 notes per revolution.
The Bureau produces, on average, about 38 million notes a day. That's pieces of paper, for a full face value of approximately $400 million a day.
To print that much money requires 3 tons of special ink a day. The exact formulas are kept secret, but black ink is used for the front of the bills and green for the back. Once the plates are inked, the paper can be added. The fronts and backs of all currency are printed separately. The fronts are always printed after the backs, so that the portrait will stand out clearly. It's critical that the paper be lined up properly. The press operator removes any sheets that have slipped out of position. Finally, they're ready to start making money. At full speed, the presses will churn out over 268,000 bills an hour.
The United States currency is printed by the intaglio printing method. So we actually emboss the paper, forcing the paper into the engraved lines. So you have that raised feel to the print.
Before printing is complete, the bills must pass an exhaustive inspection. The inspectors first make sure the sheets don't stick to each other. Electronic sensors will scan every note. They check the placement of the security thread and the watermark. A sheet is rejected if the space between the edge and the printing is greater than 1/10 of an inch. Other sensors check the density of the ink. The sheets are flipped twice to check both sides. Machines can make mistakes, so a technician inspects samples to catch any errors that might have slipped through. Now the sheets will move on to the final and critical stage of becoming money. Each note will be given a serial number composed of letters and digits. The serial number is a banknote's birth certificate. The number is printed in green in 2 places on the front of every note. The letters indicate the Bank of the Federal Reserve that asked for the money. In addition to the serial number, the press also prints the seal of the Federal Reserve System and that of the U.S. Treasury. The points on the Treasury seal serve a security function. They're very difficult to photocopy. For the final inspection, sample sheets get checked by 2 operators. The sheets that pass this inspection are now ready to make the final cut. $100 at a time, they're sliced into sets of 2 notes, then into individual banknotes. Hundreds of hours of labor have turned scraps of fabric and a few drops of ink into the world's most valuable currency. The finished banknotes are bundled into stacks of 100, then bound into blocks of 1,000. Each block is shrink-wrapped and barcoded. The Federal Reserve will use the barcode to keep track of the amount of money that's printed. Manufacturing U.S. dollars is one of the most profitable businesses in the world. Every new banknote, from a $1 bill to a $100 bill, costs just the same, 4 cents.
We manufacture a product that it's always easy to explain to people what you do. When asked what you do, you say you make money, and people know exactly what you're talking about. No matter where I am in the world, people know our product, they use our product, and they'd like to have more of it.
All new banknotes are sent to Fed banks, such as the Federal Reserve of New York's Check and Cash Processing Center in New Jersey. The Fed monitors every shipment from arrival to departure.
It's our responsibility to keep track of every single piece of cash that comes in the door. So the inventory of money that's in the possession of the Federal Reserve is of critical importance.
Most of these new bills will replace worn-out notes. The remainder is new money ordered by the New York Fed.
It's entirely at the demand of the public. Whatever currency the public demands and wishes to buy from the Fed, we supply to it, and that expands and contracts.
The New York Fed has the special job of supplying currency not only to its regional banks, but to all foreign banks as well. Almost 2 million new banknotes arrived here in 1999. Each of these large crates can hold up to 300,000 notes worth as much as $30 million. To increase efficiency, the Fed began using guided robots in 1992. Each robot's path is programmed down to inches to reduce wasted movement. This robot is entering the most important room in the building. It's the largest cash vault in the world. It's 3 stories tall and almost the length of a football field, though the exact dimensions are kept secret. That's because at any one time, there's from $70 to $90 billion stored here. Around the clock, 4 automated cranes retrieve and deposit crates of cash. Some of the crates hold used bills, others hold newly printed ones. Remarkably, much of this money will end up outside the United States. In fact, 2/3 of all U.S. currency, $360 billion, is now held in foreign countries. This fact, along with the spread of digital copiers, has created an enormous problem.
The fact that the dollar is traveling into areas of the world that were not open to us 20 years ago, combined with the fact that people travel much more so than ever before, really makes the dollar a ripe target for transnational counterfeit activity.
At the Secret Service, the extent of the problem is clear. This suitcase was confiscated at a New York airport. And these fakes are by no means the best.
Here in Counterfeit Division, we see everything ranging from this highly deceptive $100 note that's produced in Colombia all the way down to this inkjet-produced counterfeit $100 note that was probably produced in someone's basement or garage.
Details about these counterfeit notes are entered into a database at the Secret Service. The computer will identify other fakes that have similar features. Document analyst Scott Bradley then goes to the file vault that holds samples of other counterfeits. He's looking for the bills that the computer identified as possible matches with the new note. He uses high magnification to hunt for tiny defects in the printing.
When I find a defect, then I'm going to try and match that defect on my new note to a defect of a note that I pulled from the vault.
This time, Scott believes he's found a match. The printed lines on the edge of both these bills have the same tiny hitch.
For the counterfeiter, the toughest part of making a good counterfeit note is simulating the paper.
And the toughest feature to simulate is the watermark.
This is a note that we're seeing under normal lighting conditions, a counterfeit note. You can sort of see that there's a watermark image there. When I change the light source to a transmitted light, a light that's coming through the note from underneath, then we're able to see the simulated counterfeit watermark image that's on this note. When I change to an ultraviolet light source, this particular note changes so that I can still see the watermark. And on a genuine note, a true watermark wouldn't behave this way under ultraviolet light.
It's not just the watermark, but the paper itself that's different under ultraviolet light. When the light changes to ultraviolet, only the fake paper, which contains chemical whiteners, remains visible. Forensic scientists also use other methods to extract valuable clues from fake money. First, the notes are bathed in a special chemical. The chemical will react with any amino acids on the paper. Amino acids are residue left by fingerprints. When the bills are heated, an amazing transformation takes place. These could be the fingerprints of the counterfeiter. Sometimes, scientists must use more high-tech means to get fingerprints. This fake note has been treated with a special chemical. Now it's examined through orange glasses. When a laser light is turned on, the fingerprints glow. The Secret Service can compare these fingerprints to those in a special database that holds the fingerprints of all U.S. citizens convicted of a misdemeanor. If there's a match, they may have found the counterfeiter. In 1999, the Secret Service was able to arrest almost 4,000 counterfeiters.
I think the #1 reason counterfeiters get caught is greed. They can't wait to try to pass the product that they've produced. Each time a counterfeiter passes a note, he is helping us because that creates new evidence, either through the actual counterfeit notes or through witnesses that help us identify him.
But the most dangerous counterfeiters remain at large. They're the ones who produce the so-called super note, a fake $100 bill that looks amazingly authentic. The The Secret Service believes that the supernote is printed on the same type of intaglio presses as genuine U.S. currency. These Swiss-made presses are so expensive that the Secret Service suspects a foreign government may be involved. So the hunt for the counterfeiters goes on.
I think we always have to remember that the criminal mind is sufficiently creative that we always have to keep a jump ahead of them, and that means constantly changing.
The changes to currency will occur much more rapidly than they have in the past. We project that currency designs will have to be changed, or at least augmented with new security features, every 7 to 10 to 12 years or so.
But there's one thing about U.S. currency that won't change, and that's the role of the Federal Reserve as its guardian. Most Americans don't understand how their central bank functions. But at Federal Reserve headquarters, they're trying to change that.
One of the reasons so many of us support this program is its impact on the students who participate.
These students are finalists in an annual competition called the Fed Challenge.
And have fun, but remember, central bankers never smile.
Like the real Board of Governors, these would-be central bankers argue the fine points of monetary policy. The winner will be the team that best understands the tremendous changes sweeping through the economy.
What we at the Fed have to try to do is to say, what's really happening in the economy that makes it do so fabulously well, and what's the best thing we can do to contribute to that? That's our biggest challenge.
The winner is Midland, Texas.
These students have developed an understanding of the real purpose of the world's mightiest bank.
The Federal Reserve cannot create growth and prosperity. The American people do that. Our job is to try to make sure that conditions are in place that enable them to do their thing, and all of our decisions are made based on that.